Welcome to your BetterGradesFast.com live online tutorial. It is my pleasure to serve you today. We will now start our prayer. I politely ask if you are not comfortable with a Christian prayer, please turn your volume down for 15 seconds. Heavenly Father, kindly direct me to meet each learner's needs. Please direct each learner to clearly understand all that is necessary for success. In Jesus' name, Amen. So we begin today with the joke of the day that's brought to you courtesy of Rochelle. So the joke of the day, it's a very stale joke, but we would do it nevertheless. So what is a butterfly's favorite subject?
I don't know, sir.
It's mathematics. That's a butterfly's favorite subject.
Cool one.
It's mathematics. So guys, what we are going to do today is continue with our past paper sessions. So remember, this is the Form 4 to 5 math past paper session. So the last question we'd have ended on would have been this question, right? It would have been this right angle triangle, and we need to express C in terms of A and B. That would have been part A. And we need to write in terms of A, B, and C an expression for sine and cosine, right? So we wouldn't be doing any Kahoot games today. So we want to focus more on the paper 2 problems here, which is a little more intuitive. It requires a little more knowledge and understanding of your problem. So when you're given this problem, as I would repeat, so when you're given triangle problems in the CFC syllabus, there are two things you need to understand, right? Always ask these questions when you're about to solve a problem like this. So the first question you need to ask is this: is it a right angle triangle? That's the first question you ask yourself. Depending on what you answer, there are steps involved which you can use to solve. So is it a right angle triangle in this case? Can anybody tell me if it's a right angle triangle? You can message in the chat to let me know. So how would you know if this is a right angle triangle or not? Well, I hope they didn't say it or they actually did. So in this case, the question actually said it, right? So the diagram below shows a right angle triangle. So we had no worries in this case. But how would you know otherwise? So if that information wasn't given, what would make this a right angle triangle? This angle here would make it a right angle triangle, right? So if it's a right angle triangle, what do we do? Or what can we do? So I'm just recapping this because I want us to get context for this question. So is it a right angle triangle? Yes, because of that, which I just identified, the corner there. So if it's a right angle triangle, so what can we do to solve this? So one of the first things we can do is use Pythagoras theorem if it's a right angle triangle. Now, what is Pythagoras theorem used for? Anybody? Could you tell me? You can message in the chat. So what is a right angle triangle used for? My goodness, I say it already. So what is it? I nearly said it. So when do we use a right angle triangle? In what situation can you apply Pythagoras theorem, I mean? When you need to find what? Distances, right? So you use Pythagoras theorem when you need to find distances. But you're given 2, need to find 1. Right? So you have 3 sides in a right angle triangle. You're given 2 and you need to find 1. Pythagoras' theorem. Right? But what is Pythagoras' theorem? So remember, I'm recapping this for the sake of everybody to benefit, right? So what does Pythagoras' theorem state? It states the hypotenuse squared would be the sum of squares of the other two sides of the rectangle, the triangle, sorry. So we have this general form of it. H squared is equal to a squared plus b squared. H is the hypotenuse. A would be one side, B would be one side, right? So that would be the two sides on the right angle. So A could be any one of this side, B could be any one of that side. So that's how you would do that. Now, how do we find the hypotenuse? So let's recap this again. So to find the hypotenuse, you look for the right angle, which we identify here, and the side opposite the right angle is called the hypotenuse. So that's the hypotenuse there. Now that would apply for the Pythagoras theorem. It would also apply for the trigonometric ratios, so ka and tua. So that is how you would solve that problem. Now, that's one thing you can do with a right angle triangle. The other thing you can do is the trigonometric ratios. Now, you could get a tongue twister by saying trigonometric, right? But the trigonometric ratios simply is so ka tua. So does anybody remember that? So sine would be opposite over hypotenuse. So that would be the so part. It's just a mnemonic to help you remember it. So sine of the angle would be equal to opposite over hypotenuse. That would be the first one. The second one would be ka, which is cosine. So if we were to write the expression for this, it would be cos or cosine would be adjacent over hypotenuse, or ka, to help us remember it. And we have the last one, tangent, or we fondly know it as tan, would be opposite over adjacent. So that would be the three things involved here, right? So we can use Pythagoras' theorem. Again, when do we use Pythagoras' theorem? We use it when we have a right angle triangle. We know two sides, we need to find for one. That's when we use that. Second thing we can do is the trigonometric ratios, SOHCAHTOA, sine and cosine and tangent. When would we use this? We would use this when we have a side and an angle included. Right, and by angle, I do not mean the right angle. I mean an angle other than the right angle. So in this question, the angle given is theta in this case. So because we have theta and we have the sides involved, we could use the trigonometric ratios, right? So remember this, in a right angle triangles, two things you can do: Pythagoras' theorem or trigonometric ratios. Either one. So Pythagoras theorem only used when you have to find distances alone and you're given two. The trigonometric ratios, you must have an angle and a side. And that would be the context in which you would use that. So before I rework this problem, because I want us to get the context, because we need to work problem 1 and 2, let me know if you're feeling confused about the situation, when to use Pythagoras or when to use the trigonometric ratios. Right, so those would be the two scenarios. So in any CXC exam you get, and you're given a triangle, the first thing you ask yourself, is it a right angle or is it not a right angle? When you're given a right angle, remember there are two things you can do for a right angle triangle: Pythagoras' theorem and the trigonometric ratios. Pythagoras' theorem you use when you have the lengths of two sides and you need to find one. Trigonometric ratios, you must have a side and an included angle, right? And it mustn't be the right angle. So that would be the two situations in right angle triangles. So let's actually rework this problem now. So it's a right angle triangle. So I would share my whiteboard. Right, so let's actually solve this triangle. Right, so I'll try to draw it back as best as I can. So we have the right angle here. We have the side A, we have the side B, and we have the side C, and we have theta here, this angle theta. So let's see what the question asks us for. We need to, so to say, using the diagram, express C in terms of A and B. So the question asks us to find C here in terms of A and B. So it in effect is asking us for the length of side C. Now the question asks us for the length and it gives us the other two lengths. So which one would we use? Would we use Pythagoras' theorem or would we use the trigonometric ratios? Well, the question said to find the length of C, which is one side, we are given the lengths of the other two sides. So in part A, this is what we would do. We would use Pythagoras' theorem. So I'll put a note here so we can follow. I spell it wrong. Pythagoras' theorem. Right? And why are we using it? We need to find C, right? Or the length of side C. And we are given the length of the other two sides. Right? So once you need to find a length and you're given the other two, what you can do is use Pythagoras' theorem. Pythagoras' theorem states, it says the hypotenuse squared is the sum of the square of the other two sides. So usually what I encourage students to do is write the formula down. It helps put a guide in your mind where the question is going. So we have a squared will be a squared plus b squared. Right? This is the general form for Pythagoras theorem. H is the hypotenuse, a and b are the other two sides of the triangle. So in this question, how can we locate where this hypotenuse is located? Look to the side that's opposite to the right angle. So in this case, h would simply be c squared. A squared, let's keep it consistent. A could have been any side, B could have been any side, right? Once is the two sides on the right angle here. So let's keep it consistent and leave A as it is. So it would be A squared and B squared. Now, the last step, we need to write C in terms of A and B. So we need to basically solve for C, what C is. Now we have a square here, right? And we want to just write what C is. So what we need to do is take the square root to get rid of that square. So we'd have A squared plus B squared as the answer. Right now, just a point to note that usually when you take the square root, there's a plus or minus sign associated. But remember, distance, real distance, is always measured in without negatives, right? So we just be considering the positive side, right? So that's just a note to take into consideration. So going back to our problem now, we would have this. We would have, if we were to express C in terms of A and B, we know now that C would be the square root of A squared plus B squared. That would have been the first problem using Pythagoras' theorem. So before we go ahead, we know if you understood how I arrived at the problem, how I arrived at the solution, and my thought process involved in solving the problem. Wonderful. Good job, guys. So now let's look for part B now. So we need to write in terms of A, B, and C an expression for sine theta and cosine of theta. So let's go back to the whiteboard and work this one out. Again, let's make our drawing of the right angle triangle. So I'll try to draw it a little bit neater this time. Right. So we have this right angle triangle again here. Right. So we have this much better. So we have the same right angle triangle. This side is A, this side is B, this side is C, and we have theta here. Right. Now we know what the hypotenuse is. So the hypotenuse, anytime you're given a trigonometric ratio question, sine, cosine, theta, always identify your hypotenuse. It's the easiest thing to identify. So the hypotenuse would be right opposite to the right angle. So this line in blue here would represent the hypotenuse. The hypotenuse is really C. Now, let's consider the angle. So we need to find the opposite and the adjacent in relation to the angle. Now, what is the angle given? The angle given is theta. So to find the opposite side, just look at what the direction the angle is facing. We already identified the hypotenuse, so we know C is not the opposite side. The opposite would be, in this case, it would be A, opposite to the angle theta. And the only side we are left with now is the adjacent side, right? Which would be right next to the angle if you think about it like that. So B would represent the adjacent side. We know the hypotenuse, and we also know the side that's opposite to the angle theta. So just to make sure we on the same page, let me make sure you guys follow this so far before I proceed to solve the problem. Just indicate if you are confused or not, how I identify the opposite side, how I identify the hypotenuse, and how I identify the adjacent side. Right now, the only difference between this problem and some of the problems you have seen before, this one only has letters, right? So don't get confused. Now, why did I use the trigonometric ratios here? Well, I need to find what sine theta is, and I need to find what cosine theta is. So the biggest hint there is the trigonometric ratios, right? So in this case, that's what we do, right? So we are asked to find sine theta and cosine of theta in terms of B and C. So sine theta, cosine of theta. So let's tackle one first. So let's work out sine first. So we need to use our trigonometric ratios, right? We are given an included angle and a side. So what is sine theta? So let's write the formula. As I always say when you're solving these problems, it's a good habit to write the formula. It helps guide you. So sine theta would be SOH, opposite over hypotenuse. So sine will represent opposite over hypotenuse. Right? I think the question actually wanted this. Sine theta plus cosine theta. So we need to find sine and then cosine. So what is opposite and what is hypotenuse? Well, we just work it out. Opposite would be here. Hypotenuse would be here. So opposite would represent the letter A, is that side. And hypotenuse would represent the letter C. So opposite over hypotenuse would be A over C if we use the formula. Remember, this is straightforward. You just need to remember it. Once you remember it and identify the sides, we are all good to go. So let me know if you are confused how I got A over C before I do cosine of theta. Wonderful. So I'm going to set up the next question for you guys, and I'm going to give you a minute, and you can message me if you think you got the answer. So what we're going to find now is cosine. Since we already find sine, we have this part checked out. We need to find what cosine of theta is. So using our trigonometric ratios, or on the mnemonic, so CAH, we know CAH, CAH, would represent adjacent over hypotenuse. So take a minute, guys, and let me know what you would write as your final answer. You can message me. Take a minute starting now. Let's actually see how we get this one out. So cosine is adjacent over hypotenuse, right? So we have this acronym down, the rule. So what is adjacent? What is hypotenuse? So let's identify the problem. So adjacent would be this side. It would be the side B. Hypotenuse would be C, which we already established. So we would have B over C as adjacent over hypotenuse. So let me know if you guys understand this before I go into the last part of this problem. Right? Don't get frightened if you see letters. Once you understand the concept, cosine is adjacent over hypotenuse. You know what adjacent is, you know what hypotenuse is. You put the two together, boom, you get the answer. Wonderful job, guys. So now let's actually see what does the question want us to do. It wants us to find the expression for sine of sine theta plus cosine theta, right, in terms of A, B, and C. So, okay, let's go back to the problem and do this. So we need to find that. Cosine of theta plus sine of theta. Excuse me, theta, it's not the most artistic. So cosine of theta, we just found that here. It would be B over C. Sine of theta, we found that in the first part here, would be plus A over C. So going back now to the problem, I just want to write the solution down. So this is the steps. So if you guys want to take a screenshot of this, it's fine. This is for part B. You can go ahead. I'll give you a couple seconds. Take the screenshot, or if you're writing it down as well. All right, so let me move on now to the question. So I'm going to write the solution to the side of this problem. So we would have A over C plus B over C. So using the results, show that sine squared plus cosine squared is equal to 1. using that expression. Right, and also the answers from part A and C. So let's tackle this problem stepwise. Don't get scared when you see it. Let me just clear my screen. So we need to show this. Right, using our answers from part A and B. Now let's write it down what A was. So from part A, we understand that C was the square root of A squared plus B squared. Right, or that's the first part. The second part, we understand that sine theta plus cosine of theta will be A over C plus B over C. That's the second part of the problem. So that's the information given. So let's go back, make sure we see the question that wants what it wants. So it looks complicated, but it's not as complicated as we think it is. So we need to find sine squared plus cos squared. Right now, you would see I wrote something like this. So what does that mean? Sine squared. It means exactly what you think it is. So it's sine theta multiplied by sine of theta. That is how you would get sine squared theta. But remember, we'd have found for what sine theta is. Right? And we'd have found for what cosine of theta is. Right, but we need to use the results from A and B to do this. So that's where it gets complicated. We have to use the results. So if we have those expressions, so let me break it down as simply as I can. So we need to work this one out. What do we have to work this part out? We have the following from part 1, and we have this from part 2. Right, so I want you guys to attempt it before I solve it. Right, just brainstorm it. Take 2 minutes and let me know the process you would take to get through this. I don't want to just do it and you guys don't make an attempt. Right, so take 2 minutes beginning now. Proceed to attempt. I'll proceed to solve it, and then I would come to you guys and work it out. Right, so remember, using the results we need to find for this. So start now. All right, guys. So by now you should be through the problem. So if you're confused, that's fine. It was a pretty tricky question. So now let's actually go and solve this question one out for good and for all. So we are left with this. We need to find we need to show that sine squared theta plus cosine squared theta, we need to show that that's 1 using the information we have before. So first, what can we do to make this easier or easier to understand? Now we need to be fully aware of square terms in this case. So what we need to write is this: sine theta plus cosine theta all squared, and write this as though it was a quadratic we are solving. So if it was a quadratic, this is how it would look. We'd have had a plus b multiplied by a plus b, right? That would give you a plus b all squared. So we'd have gotten a term in nx squared. So we'd have gotten a squared, a to the power of 2. We'd have gotten a term in b squared, b to the power of 2. And we'd have gotten 2ab. Right? That would have been the problem if we were using a. If we let sine be a, if we let this be the actual value a, and this be b, this is the expression we would use to get it. And what would we be left with is simply this expression. So sine plus cosine squared would give us this. Sine theta squared plus cosine squared theta plus 2 by sine by cosine of theta. That would have been the problem. So what we are really looking to find is the following. We need to make this the subject of the formula, right? So how can we make that the subject of the formula? Well, this is what we can have. We making that the subject of the formula, we'd be left with this. Sine of theta squared plus cosine of theta squared would be equal to sine plus cosine, don't forget your thetas, all squared, which would be this part here. And this plus sign would need to change into a minus sign, right? We'd subtract that from both sides. So what we'd be left with is this. Sine of theta squared plus cosine of theta squared would be sine plus cosine all squared minus 2 sine theta cosine theta. Now let's take a step backwards before we go. This part we already found in the second part of the problem, part B. Sine plus cosine would have been a over c plus b over c squared. So that would have been that part. The second part would have been this: a over c multiplied by b over c. So this is the expression we'd have gotten so far, right? So all we're doing is put in what sine theta is, put in what cosine theta is, which we found in part 2. This was the hardest part, writing the quadratic in terms of the sine. Right, so we aren't done here yet. What we can do is simplify. Now this is all squared in the brackets. So what you can do is write this as a complete fraction. So this would simply be A plus B over C squared. This would simply be minus 2 over 2AB by C squared. So that would have been that part of the solution. So again, I'm going to give you guys 1 minute to see if you can see the problem from there now. Right? We only have about 2 minutes left for class. Take 1 minute, see if you can reduce it now to get your 1. When I come back, after the 1 minute, I will proceed. I want you guys get a little bit of thinking to any problem. Go ahead. Right. So let's proceed now. I run out a little bit of space, but let's go. So how can we expand this? This is a quadratic again over C. So let's get rid of the square sign. So we have A squared plus B squared all over C squared. And we would have plus 2AB. We would also have minus 2AB over C squared, right? So the first part is when we expand this. The second part would just be writing back that. Now, because they are both over C squared, what would we get? We'll look at it this way. This aspect here is plus 2AB over C squared. This is minus 2AB over C squared. So these two terms would cancel each other out. So what would be left with would simply be A squared plus B squared over C squared. Right, so let me just clear my drawing. So what we'd be ending up with is this. When we do the algebra. Right, but remember in part A, what was A squared plus B squared using Pythagoras Theorem? A squared plus B squared was equal to C squared. So we'd end up with C squared over C squared. Right, so let me just quickly recap the problem here, right? Because I know it could be a little confusing for you guys. So let me just share back the problem so you can see what's going on. Right, so to do this problem, this is the steps you would have taken. We need to show that, right, using the knowledge from A and B. So in order to do that, you would need to understand quadratics. So you'd have had to write this. Sine theta plus cosine theta whole square. That is the first thing you'd have done, right? Because you'd have been using this knowledge here. So what would that be? So using quadratics, that would be equivalent to sine theta squared. So your first term squared plus your second term squared plus 2AB, right? Or 2 sine cosine theta, right? So when we expand it, this is what we would get. So that would have been step 1. Remember, our goal is to find what this is. So make this the subject of the formula would have been your next step. So if you make that the subject of the formula, this is what you'd be left with. sine theta squared plus cosine of theta squared, right, which is this, which we need to find and show that it's 1, would be equal to this. So that remains on the side. Squared. This, we have to bring it on the same side, so we subtract it. 2 cosine theta sine of theta. So that is what the first step would have been. So we need to find this, so we need to solve. So how can we write this? Well, again, this is another quadratic, right? But we know what sine theta plus cosine theta is when we work it out. That was simply a over c plus b over c when we work it out. So if we were to substitute that here, we would get a over c plus b over c all squared, right? We'd literally replacing this part in the brackets here. Now this part we could find out by saying, we know what cosine is, it's 2 by b over c, and sine was a over c. Right, so we substitute for cosine, we substitute for sine. Now we need to simplify the algebra in the terms. So how can we expand the brackets here? Well, first let's write it in an easier form where we can see. This can be written as that, all squared, right? That will be the first part of the expression, and we can write this as 2ab over c squared. B and a would multiply by each other, and c by c would give you c squared. Right, now how can we expand this in the brackets? Now, if we expand the top part, we would get a squared plus b squared. I know we're going a little bit over time, but I just want to explain this. Plus 2ab when we expand the brackets on top. So just a plus b all over c squared. That would be the solution there. We now subtract. Sorry, I forgot the 2 here. 2 from here. So we get minus 2ab all over c squared. Now this is where to be pay attention to what's going on. Right? So we have 2ab c squared here plus 2ab c squared, and we have minus 2ab c squared. So both of these terms would cancel out. So what would be left with is this. A squared plus b squared all over c squared. Right. In this question, when we use Pythagoras theorem, we got an expression like this. C squared is equal to a squared plus b squared. So what can we replace a squared plus b squared by? We can replace that as c squared over c squared. Now c squared over c squared would give you the answer of 1. And that would have been your solution. Right, so I know it was a little long. There's multiple steps involved in this problem. But this is how you'd have approached doing this. Right, so we're going a little bit over time, but I didn't want to stop and leave you guys hanging on this question. So let me know before I go if you understood how to do this problem better now with the steps I explained. Right, I know it's a lot going on, but let me know if you understand the steps. Remember, you're trying to show something, so you have to validate all your steps in the problem. Right, so it's not just knowing Pythagoras theorem, they could also incorporate things like quadratics. So good job, guys. So we have come to the end of this tutorial. It was a pleasure serving you today. Please take a minute to fill out the quality control questions that would appear at the end of this meeting. Let us know what you'd like us to do differently and how we can improve to better serve you. Thank you for choosing BetterGradesFast.com. To have a blessed evening, guys. Take care.